So just to make sure you're in the right place, you are here. We're going to be talking about Atlas and WebAPI over the next hour. And our agenda is to provide an overview of the Atlas code and WebAPI code and talk a little bit about the team behind the projects. We're going to talk a bit about the process that we have for communicating amongst the team members and getting things done, which is evolving as we speak. The development environments that you will need if you want to get started with, I'd say, poking around and start developing in the Atlas code base as well as WebAPI. And as part of that, I'm going to take you through the code base itself, how it's organized, try and walk you through some examples and kind of try and give you a feel for some code that already exists. So with that, taking this directly from the book of Odyssey, Atlas and WebAPI are part of the Odyssey open source software architecture that aim to provide standardized analytic capabilities built on the foundation of the OMOP Common Data Model. So hopefully, since you are here, you are familiar with the OMOP Common Data Model, and so much that you are able to store patient-level data there and use tools like Atlas, WebAPI, Hades, etc., to generate evidence. And so for today's talk, the target audience is going to be folks that have some familiarity or interest in Java development as well as JavaScript development. And I would just kindly ask if you're not speaking, if you could just place yourself on mute so that there's no background noise, I'd appreciate it. Thank you. Okay, so what are we not going to cover today? So we are not going to cover how to use Atlas. There are a number of really good resources out there on the internet. I'm going to point out the Eden Academy in particular. So there are trainings on the Atlas and Web API infrastructure, which I'm going to touch on a little bit today. There's a full Atlas tutorial that Chris Knoll has put together, and there are many other Odyssey-related trainings on that website. There's also tutorials on how to use Atlas on the Atlas Wiki, and if you want to look at previous Odyssey Symposium talks and recordings, there's just a deluge of knowledge about how to use Atlas to generate evidence. But what we are going to talk about today is the technology underpinnings for each of the tools. So starting from left to right, we have the Atlas web application. The Atlas web application is built on Knockout JavaScript, and Knockout is a framework that we'll get into more detail later, but it's effectively allowing us to organize the JavaScript code. And we, as the development team, we use Google Chrome both for using Atlas and for development. So I'll take you through a little bit about how we use Google Chrome, both from a user standpoint and from a developer standpoint. So Atlas does not work unless you have a web API, an Odyssey web API specifically, to facilitate communications to and from both the web API database itself, which is a Postgres database, and it also facilitates communications with your OMOP CDMs. So just to talk a little bit about web API is a Java 8 REST application, and if you're not familiar with that term, REST is short for representation state transfer. It's a HTTP protocol, so that when you are working with URLs from Web API, there are certain verbs that you could use to put, get, post different information, and we'll touch on that a little bit later. So let me just take a minute to talk about the project team. The Atlas and Web API working group is an Odyssey working group that resumed earlier this year to re-engage with the community and to provide better communications visibility into the work that we're doing. We meet the first Wednesday of the month at 9 a.m. Eastern. And if you want to sign up and get involved in the working group, you can go to odyssey.org/working groups, Odyssey work groups that is, and click the button to join the work group. Our work group leads are Alexi from Odysseus Data Services, myself and Chris Knoll from Janssen. And I'd also like to give a shout out to Ajit Landi, who has been helping steer some of the new development work that's happened over the last 2 releases. Our work group is organized in teams. We try and primarily use GitHub for communicating on issues, but we do want to start to evolve the use of teams to try and get more maybe real-time asynchronous talking, or potentially even expand our meetings if there are more people that want to get involved with development. And I also wanted to lay out some of our objectives. These were our first quarter objectives, which are now our second quarter objectives because we have not achieved them. But the objectives that we have are to improve the deployment of Atlas and WebAPI. So currently it can be a challenge to deploy these tools out. And as such, we want to get community feedback on our current deployment process and then try and identify places where we can make that better. So as we go through this today, if you're a developer and you're getting started and you're finding it maybe challenging to understand the directions or something's not clear, that becomes an opportunity for us to improve the documentation and hopefully the deployment of the tools. Objective 2, which seems similar but is a little bit different, is to improve the documentation of the Atlas and WebAPI code base. So we want to document 100% of the Web API endpoints, and there is a URL where those endpoints are currently documented. We don't really make that very visible, in part because it's just not that complete, and we'd like to improve that through a community effort whereby if people are diving into the code base and as they get an understanding of the code, an easy way to make a contribution potentially is to add comments to the code that then become part of the documentation. So as part of the working group, I just wanted to talk about how we are approaching our development process. And so first and foremost, and I've put a star here to note that we do everything through GitHub issues. So one of the things that I'd like to just describe to the group here is issues is kind of an overloaded term. There are issues that can help us identify documentation opportunities and clarifications. You can post an issue about bugs that you find or bug fixes you'd like to contribute. If you have new features that you would like to see in the platform and want to contribute to building those are great issues to post. And then general questions are, of course, welcomed. And we certainly need help on triaging issues. So if you have an interest in getting involved in the project and you'd like to help us with triaging issues, please reach out to me or Chris Knoll or Alexi, and we will try and loop you in so that we can get some help. I'm going to talk a little bit about our release process and our roadmap development here. So for development proposals, we want you to post that new issue to GitHub, as I mentioned. If you're not sure if you want to post it on the Atlas repo or the Web API repo, it's fine if you just want to post it, and we'll find a home for it if it's in the wrong place. The issues, as I mentioned, we want to start prioritizing documentation types of issues. So if something is not clear or it's not documented well, you could post an issue and help us update that documentation. Additionally, bug reports. So as you are maybe using the system or as a developer, maybe you're getting into the weeds of how things are working, you may find that there's a bug or you may find that something's not working to your expectation. Feel free to post an issue, provide as much detail as possible, in particular your environment, the build that you're using, any steps that you can describe to reproduce the problem. And of course, like, don't share database credentials or other sensitive information when you do that. New features. So if you have a use case for a new feature, describe it. Start by at least describing I would say the business case or the use case that you have before we dive into any sort of development, designing, or solutioning of that problem. There may be opportunities to either reuse or expand existing functionality or just think through different ways in which we could accomplish the goal for that particular feature. And then, of course, just any general questions. If you're not sure how something's supposed to work or you can't get something working, just post a question. And again, we try and do our best to answer those questions as best we can. I know Chris is on the call and he does an amazing job on the forums. And we try and monitor both places, GitHub and the Odyssey forums. Okay, so let's talk a little bit about how we do releases. So new development work is contributed by creating a pull request. A pull request, if you want, there's a great resource that Adam Black has put together on the open source community channel where he actually goes through fixing a bug for database connector. The process is nearly identical for Atlas. Basically, you are either going to fork the repository or you are going to open a pull request directly on the Web API or Atlas repository. You contribute your code, and then we will review the contribution, we being the Atlas and Web API project team. Once we've reviewed the pull request, we may have feedback, things to change, that sort of stuff. Once the branch that has the new code is complete, the work is then merged into the master branch, which is effectively our development branch. So as we are adding new features or fixing bugs, and all of that is going into the main master branch. Once we have enough fixes or all of the features are done, we aim to have quarterly releases of Atlas and WebAPI. Sometimes those timelines are shifted because sometimes things are discovered during testing, or we just have delays in our work. And so our aim is for quarterly releases, and so we try and stick to that as closely as possible. We manage the releases using milestones in GitHub, and if you're not familiar with that, there's a milestones tab off of the issues page in GitHub, which I can show. And this just provides a way for us as a development community to know what is being planned for a particular milestone. It provides us with some sense of how much is complete and when we're ready to release. So the next part is, once we feel like the release is ready, we go through testing of the code. So when all of the code in a particular milestone is ready, Odysseus has developed both automated and manual integration tests to make sure that there are no bugs or no regressions in this way. Other teams that want to help with the testing, like internally at Jansen, we are using the latest build off of the master branches to just make sure that we don't find any major bugs or showstoppers with a particular build. And when that build is stable, we will tag and make the release inside of GitHub. So what goes into a new release of Atlas and WebAPI? So as I've mentioned, we are prioritizing documentation. So any and all work that you would like to contribute around documentation is going to get into any upcoming releases. We certainly welcome and encourage people to get involved with the project, and documentation is a great way to get started in learning about the code base, as well as contributing to the body of knowledge that is the Atlas and WebAPI documentation. Bug fixes, of course. So if something is broke and you feel like you could fix it, just post an issue, or hook into an existing issue if someone has already reported it, and just say you'd like to try and fix it, and we can support you in that process. And new features are a bit different in that they're going to require a bit of discussion with the project team, and just making sure that they're built in a way that meets our general patterns of development, as well as meets the timelines that we have for each release. So if something's not ready for a particular release, we can always move it out so that it goes into a subsequent release. But we just like to have those discussions up front to just make sure we understand the project's timelines and that sort of thing. Okay, so with that, I'm going to dive into the Atlas technology and the stack a bit. So as I mentioned earlier, we are using a framework called Knockout JavaScript, and Knockout is a framework that supports the model view model pattern. And if you're not familiar with this pattern, don't worry about it just yet. I'm going to kind of go through that when I go into the code. And I just wanted to leave a few learning resources out here, and these slides will be posted somewhere, so you'll be able to get to these links. Knockout has a great tutorial website. If you're interested in getting involved in the project, and in particular learning Knockout, they have a great set of tutorials. It's all web-based, so you can kind of code up different examples and learn the framework from the bottom up. There's also a nice video on the MVVM pattern that you could see on YouTube. And we do make use of JavaScript ECMAScript 6, which is basically providing additional functionality and syntax that you will see in the code base. So if maybe you are new to JavaScript, or you've worked with an older version of JavaScript and you're jumping into this code base and you're seeing syntax that's not familiar, this may be a good resource to review. And finally, we use a component called required.js, and what required.js allows us to do is to load different modules, so we can create smaller JavaScript packages and use require to basically load those smaller modules when they are needed in a particular part of the code base. And we'll show you how that works in a second. So what do we need to do Atlas development. So some of the tools that you're going to need to have Git. So you're going to need that for working with your source code. You're going to need Node.js. In particular, the npm command is used for building the JavaScript project. You're going to need a web server to host your Atlas code. I've just listed out a few here. I'm going to show you on my machine. I use IIS, but you could certainly use Tomcat, or if you're a Python developer, you may use HTTP server just to host things. You'll certainly want to have Google Chrome, and the Chrome developer tools are bundled with Google Chrome. And this link here is a useful resource if you want to get deeper understanding of the development tools that come with Google Chrome. There's some other useful open source tools for JavaScript development. I'm going to just note a couple here, but you can always use your preferred JavaScript IDE. I particularly like Visual Studio Code. I know Chris and others use Brackets. I've used Brackets as well. It's a good tool. I just happen to have an affinity for Visual Studio, having a Microsoft development background. And I guess the final note, as I've underlined here, you're not going to be able to make use of Atlas without WebAPI. So if you want to get started with Atlas development, you are also going to need to tackle WebAPI, which we'll do coming up. So getting your development environment set up, you should follow the Atlas installation guide. It's effectively a very similar process to what you'll want to do for development. Effectively, you're installing the tools that I just showed. You're going to clone the Atlas GitHub repository to your machine using Git. This is the command that you would run to put the files on your file system. You would then run npm, which is the executable that comes with Node.js. This npm run build will build the project. It'll effectively download all of your JavaScript dependencies, and then start up a web server to host the code. And again, I'm going to kind of take you through how I have this set up on my machine so that you can see. So let me step out of PowerPoint and I will give you a demo of how my environment is set up. And then we can dive into the code structure of Atlas. And then I'll just take you through the prediction module a little bit to kind of show you how some of that code works and hooks into WebAPI. So let me stop sharing here. Okay. So let me start by showing you my file system. So within my hard drive, I have a Git folder, and under that I have an Odyssey folder in which I have all of my Odyssey GitHub repositories located. So here is my Atlas GitHub repository code. I've just cloned this from GitHub, as I mentioned before. And on my local machine, I have installed and configured Internet Information Services. This is my web server that is now running on my machine. If I expand out IIS under the default website, I have added the Atlas application. You can add applications in IIS by saying just add application here. You can provide an alias. In this case, I'll just call this Atlas 2 for a second. And then you could tell it where to find the code. So for me, that's going to be under my Git directory under Odyssey and Atlas. And I will not create this because I already have it here. And what that'll allow me to do is now I can browse to my local host /Atlas. And because I have WebAPI running on my machine, which I'll show you in a bit, this will now render. One of the steps I just skipped, apologies for that. So once I've cloned that repository, I need to run npm run build, which I had already done, so that's why I unintentionally skipped that step. But once you have run npm run build and it downloads all of the JavaScript for you, then the website will start up. And you'll see that this doesn't take too long on my local machine, but you could start to just see how all of this is downloaded. Okay, so I won't wait for that to finish. Let me take you through the code itself. So taking a quick look at the home page, let me just close the developer tools for a second. We'll get back to that in a moment. So Atlas has a layout of a left-hand menu of options. It has a home page. It has some other pieces in the header. This localization piece was built by Odysseus to allow us to translate to different dialects, which is pretty cool. I stick with English because that's all I know. But the layout of this page is reflected in the index.html, which is in the root of the Atlas code base. So I happen to have that open here. What you'll see is as you're going through this code, you will start to see things like what appear to be comments, and these comments are actually code for knockout. So this KO is short for knockout, and this if statement is effectively allowing us to do things like showing or hiding different parts of the HTML page based on different conditions. So this initialization complete is part of the code base, which we will get into in a moment. But this is effectively the view. So when we talked about MVVM, there's the model, there's the view, which is this HTML, and then there is the view model, which is used to bind this HTML with the JavaScript. So within the code base, you'll see that there are a number of folders. The primary folder I'm going to focus on today is the JS folder, short for JavaScript. Within the JS folder, you're going to see there are a number of subfolders, and I'm going to just try and quickly touch on some of the, I'll say, more important ones. The first one that I want to point out is the config folder. So the config folder holds the application configuration. So if I open up app.js under the config folder has all of the values that you would use to configure the Atlas application. So as you scroll through this, I'll just point out that the app config API, the default is to use your localhost web API. And for most developers, you're probably going to be hosting your web API locally, but if you're not and you're using it on a different machine, you'll want to make a change to this. The way that you make a change to this is actually not directly in the app.js file. The way that we have allowed for local configuration is to place a file under the JS folder called config local. If I open this up, you'll see that this particular file has a form to it. It's effectively creating another JavaScript file, which allows you to override the settings that you may have. So internally, if I were to want to use a different endpoint for my web API, I could uncomment this particular block of code, which is a different endpoint that we use here within J&J, and we could make use of that in place of the local web API. So you would save this file out, restart Atlas, and then it would pick up those new changes. And when I say restart Atlas, I should be more specific. That can be done by opening the developer tools, which I hit a shortcut of Control-Shift-I, but that is also done by going to here, going to more tools, and then you can open up the developer tools from the menu here. When the developer tools are open, if you're making changes to the config local.js, an easy way to reload and kind of clear out any cache that may exist is when the developer tools are open here in Google Chrome, you can hold down this refresh button and you'll see there are some additional options that are exposed. You'll want to make use of the empty cache and hard reload. That will basically clear out any cache that you have for Google Chrome and basically start fresh. I haven't made any changes here, so it's not that important at the moment. So this is the config local. I also wanted to point out the pages. So under JS, under pages, you will see that there are a number of folders here. And if you look very carefully at this, it looks very similar purposely to what you see on the left-hand menu of Atlas itself. So for each of these modules here that are in the left-hand side, we have effectively the pages that drive the content that you will find under each of these tabs. So what I'm going to do for the remainder of the time on Atlas is I'm going to take you through the prediction module a bit. So if I expand the prediction page, you're going to see there are a number of files underneath this particular folder. I'm going to show you a little bit of the prediction browser and its corresponding view model. So again, this is the view that we use for browsing all of the predictions that are in the system. And if you're not familiar with that, let me just pull it up on the page here. So what
Anthony, oh, sorry to interrupt, Anthony. So
yeah.
it might be just me, but I'm still just seeing the config local JS Visual Studio screen.
Oh, are you not seeing Atlas?
I'm not seeing Atlas.
Oh,
I am.
sorry
Your screen is updating for me. It could be out of sync for other people. Do you want to restart your sharing just to see if it'll kick people out?
Yeah, let me just restart that just a second here. Thanks for pointing that out.
Yep. Sorry, I would have called that out if I saw it too. Sorry about that.
That's all right. Yeah, I'm glad. Thanks for pointing that out, Paul. Let me know if you could see it now.
Yes. Thank you.
Okay, great. Sure. So to kind of decompose this page a little bit, inside of the prediction page, the first thing that you will see is this what we call the browser. So you'd want to browse the existing patient level prediction designs or potentially create a new one. And so this section of the page is its own view model inside of the Atlas code base. The prediction browser.html has a few pieces to it. There's the heading title, which is that black bar that you see across the top. And then there is a div that holds two elements. There's the span, which has the button, and then the faceted data table, which holds all of the designs that are currently in the system. And because this is my local machine and I've created basically one for this conference, I just have one element inside of this table. This provides us with a view of the page, but then the next part is how does it actually get the data to display or work with these individual components? The corresponding code for this particular view has the same name with the JS extension. The JS extension has code within it that helps do a few things. The first piece is it uses require to define which modules it needs to do its work. So this particular list, lines 2 through 17, define all of the dependencies that this particular component has to do its work. And you'll see within it, there's kind of two flavors of modules that we define. So knockout is one type, and let's say services is another. So you might wonder, well, where does knockout get defined? That's defined under the JS folder, there's the settings.js. And if we do a quick search for knockout, you'll actually be able to see that this is coming from the nodes modules. This is what we download when we run that npm run build command, and it's grabbing the latest version of knockout to use. And going back to the prediction browser, the services/prediction is actually using a relative path. So it is actually going under the services folder, which is down here. And there's the prediction service. And we'll talk a little bit about that later, but you can kind of see how these are derived and loaded from require.js. They are then part of a overall function that is fed into a class here. So you can see the prediction service is used here and made use of throughout this particular module. So when the page is created, the prediction service is called, and the function it's calling is to get the prediction list. And the prediction list is effectively querying WebAPI to get all of the prediction designs that are in the system. It's then binding that to that data table and allowing it to be displayed. So let me just quickly show the prediction.js file, because this is effectively what is bridging the gap between JavaScript and the web API endpoints. So if you look at prediction.js, you will see there is a get prediction list. I scrolled past it. And it's actually calling the HTTP service to get from the web API the prediction endpoint. And if there's some access denied because security is enabled, we can handle that. So let me show you this from the front end really quick. So one of the things that is really useful about the Google Developer Tools is you can actually provide it with sources. So if I can add a folder to a workspace under the sources tab here, which I've already done. So I've added Atlas, and now I can actually see all of the code inside of the Google Developer Tools. And what's nice about this is I can actually set breakpoints on different parts of the code that I may want to inspect. So I was looking at the prediction service just a moment ago, so I'd like to open that up, have it opened here, and now I can actually set a breakpoint and kind of see what's happening here. So if I reload this page and I want to stop at this particular line, once the module is loaded, Google Chrome will actually let me stop. And now I can actually do some things from the console. So if I wanted to take a quick look at like what the HTTP service defines, I could use the Google console here to take a look at the particulars of the HTTP service. If I wanted to understand the config that's in use, since we're making use of config.WebAPI root, I could look at config as a whole, which may have a lot of options. Or I might want to just see like what is the config.WebAPI root. And you can see that it's currently pointed at my localhost web API. Now, one thing I'll also point out is Google Chrome has a really great way of viewing any network traffic that's happening. So I'm using the clear button up here purposely because I'd like to actually see when this call is made, you'll actually see the prediction endpoint that gets called from web API, and you can take a look at the response. Well, once it's downloaded, you can actually see what was returned by web API once that call was made. And because I don't have security enabled, I can actually do this. I can actually say, open this particular call in a new tab. And because this is using the HTTP GET, I can actually just do this right from the web browser and see the response that was provided by web API, which in this case is just the list of prediction modules, or sorry, the list of prediction designs.